Okay, so today we're going to go ahead and introduce rational functions. Okay, so these are when we actually go ahead and graph out rational. So our parent function for a rational looks like this. 1 over x. Okay, the way that we describe this graph is a hyperbola. And the domain is x cannot equal 0. Okay, so x can equal anything but 0. Our range is the same but with y. Y cannot equal 0. We're going to have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. If you have a sec, I would suggest pausing the video and going ahead and graphing 1 over x in Desmos, and you'll see what it looks like. Right? So if you did that, you should have got something that looks like this. So I just draw dashed lines for my vertical and horizontal asymptotes, and then you should have had one graph going there and another going there. Right? And that's what the graph of 1 over x looks like. So the nice thing about graphing these guys is that, as always, our transformations work the same as they have in the past. So we're going to look at these transformations. We're going to focus on this for today. Okay? So we're going to look at how we can transform this rational function. So this is the form we're going to be looking at. We're going to have an a value up top, x minus h, which we've seen very many times in the past, and also that plus k on the outside. So as always, h is our horizontal shift. And once again, as always, when we add a number, we actually go left, and we subtract a number, we actually go right. Our k, that number on the outside, gives us the vertical shift. So when we add a number, we actually go up. When we subtract a number, we go down. So vertical shift works a little bit more normal. Right? If a is negative, we reflect across the x-axis. So this is the same stuff. You've written down the same exact stuff in the past. Right? If a is greater than 1, we're going to have a vertical stretch. If a is between 0 and 1, we're going to have a vertical compression. Right? The one thing we're going to add on when it comes to these rational functions or reciprocal functions, okay, is where the vertical asymptote and horizontal asymptote are going to be. And they're actually pretty easy to find. Right? Whatever that horizontal shift is going to be where our vertical asymptote is. Right? And then for our horizontal asymptote, it's just going to be at whatever our vertical shift was. Right? It kind of works a little weird. Just because you got to kind of switch those words. But with all that information, numbers 1 through 3 here should actually be pretty easy. Right? So the first one, number 1, just says the reciprocal parent function is reflected across the x-axis, then translated 4 units right and 3 units down. Write an equation to represent the new function. Identify the asymptotes. So we have to do a few things. For reflected across the x-axis, we have to throw a negative out in front, right? We're going to have a negative. Okay? And then we're going to have translated 4 units to the right. And the reason I put 1 up top is because it didn't tell me to do any vertical stretch or compression. So my a value should just stay like that. Stay as 1. And 4 units to the right is going to be x minus 4 on the bottom, right? And then 3 units down is going to be minus 3 on the outside. And let's think real quick about our vertical asymptote. I'm just going to write VA for vertical asymptote. And we said vertical asymptote is going to be x equals whatever our h value is, which is 4 in this case. So to think about that, even though this is x minus 4, remember that actually means we're shifting right 4 units. So that's why our vertical asymptote's at x equals 4. And our horizontal asymptote is going to be at y equals negative 3. And we just took that from right there. Okay, so let's try 2 more. The reciprocal parent function vertically stretched by a factor of 2, then translated 7 units up and 1 unit left. Write an equation to represent the new function. So with this guy, we do have a vertical stretch by a factor of 2. So instead of 1 up top, we're going to put a 2. Okay? And then down below, we know we're going to go 1 unit left. So I'm going to do x plus 1, and 7 units up will be a plus 7 on the outside. And then all we have to do for our vertical asymptote is going to be x equals -1. That's an x right there. Remember the way I got that? I just said, hey, this is shifting me left 1, so that's where my vertical asymptote is going to be. And my horizontal asymptote is going to be y equals +7. And this last one gets a little more complicated. We said a reciprocal function has a vertical asymptote located at x equals -2 and a horizontal asymptote located at y equals 5. Write an equation that could represent this function. So I'm going to keep it basic. I'm going to just do 1 over, and then I know that my vertical asymptote would be at x equals -2. That means I must have shifted left 2 units. So to do that, I need to put x plus 2, right? And I also know that my horizontal asymptote is at y equals 5. I must have shifted up 5. So I'm going to do +5 on the outside, and I have my function. Okay, so we're going to keep it nice and basic for you guys today. So what we're going to do to practice, okay, is numbers 1 through 6 on homework 6. Okay, so go ahead and give that a try and be prepared for a quiz on Friday that'll be pretty short and easy. Okay, hope you have a good day.